if I'm looking for the x, that will be my radius, -2, times the cosine of 5 pi over 4. The cosine of 5 pi over 4 has to be some kind of root 2 over 2.
Negative.
And it's going to be negative because it's in the third quadrant. So this is really like -2 times negative root 2 over 2. Or in other words, root 2. If I'm looking for my y value from the equation up above, I know that that's the radius, which is -2, times the sine of 5 pi over 4. The sine of 5 pi over 4 is also going to be negative, being in the third quadrant, and is also a root 2 over 2. So this is -2 times negative root 2 over 2 again, or in other words, root 2, which means that my final coordinates in x and y values would be the square root of 2, comma, square root of 2. In number 4, we are going to convert, instead of going to rectangular, we're going to convert to polar. Remember that when you're going to polar, if you ever see this phrase, to polar, that means that you're looking for an answer that has an r and a theta when you're looking for coordinates. So let's take a look at what this stuff means. As I look at letter A, if I were thinking about that visually, what it's saying is that I want to end up at the point -1, 1. Or in other words, here's where I'm trying to end up. But in polar, what you have to do is you have to spin a certain direction, and you have to walk out that distance. Dang it. Sorry. It's the end of the world. -1, -1. My apologies. Well, whatever. That was kind of annoying, so I'll just do it all over again. My bad. -1, -1. Here's where I'm trying to end up. Which means I have to spin all the way around to here, walk out a certain distance. That's where I need to end up. Oh, look. This looks familiar. Triangle. 1 and 1. Man, the two sides are the same. That's weird. That means if I was looking for this angle right here, I know that the tangent of that angle that I'm talking about right there is equal to 1 over 1. How could I find the angle size? Not reverse tan. Inverse. Okay, maybe you said inverse. I'm sorry. Inverse tan. So theta is equal to the tangent inverse of 1, which you're going to find out is 45 degrees. Or a pi over 4 if you like radians. But if that's 45 degrees, how big is my red spinning angle?
225.
Very good, Adam. 225. Because you had to go 180 degrees first, 180 to get to the x-axis, and then you went another 45 degrees on top of that. So the only thing I have left to find is my radius here. How would I find that radius?
Radius is equal to plus or minus the square root of x squared plus
What is that called, actually, is what I was looking for. The Pythagorean theorem. 1 squared plus 1 squared equals r squared. When you solve it, you find out that your r is the square root of 2. What that means for us is if I'm looking for my polar coordinates, it means that I walked out the square root of 2 but I did that in the direction of 225 degrees. Again, there are 8 representations on how to write this. You could have used a pi over 4 if you want to, 5 pi over 4, I don't really care. Pi over 4, whatever it takes. There are 8 ways to write it. This is the way that my brain thought of when I was doing this problem. How many people drew the picture right away and saw what was going on?
Wait.
270 dot on here at -2. Here's my dot. That means that the distance that I walked was 2 units. If I spun 270 degrees. This is, again, only one way to write that coordinate in polar. Remember that you're talking about r comma theta. How far did you walk out, the radius, and at what degree measurement were you facing when that occurred? Okay, in these next 2 problems, I want you to think about kind of the common sense of what's going on. So number 5, you see r equals 5. What does r usually stand for? Radius. This is a circle with a radius of 5. So if you're going to write down the equation of that circle, here we go. Done. Next one, we have an angle, pi over 4. If we look at a quick picture, and we saw that in our polar graphs, we saw this kind of a thing, these concentric circles. Pi over 4 is in the direction over here. That's where pi over 4 is, or right there, or right there, or right there. In fact, if I connect all those dots, what I see is a line. And that's the line y equals x. Do you remember on the very first slide where we had that triangle that had x, y, and r in it? Do you remember that stuff? Remember there was one that was the cosine one? Was that purple or blue? Do you remember? It was purple, the x one? Okay. So if I look at this cosine from our first slide, you might recall that that cosine was x over r, or in other words, the adjacent side over the hypotenuse. Do you guys remember that? And then the other stuff, the r equals 4 times that stuff is still there. Now my goal, when I'm converting, look what the word said in the very beginning. I'm supposed to go to rectangular. What does that mean? XY. So I'm trying to get to x's and y's, and I'm writing ordered pairs, but really that's not what we're looking for. We're not looking for an ordered pair, we're looking for an equation. But your equation can only have x's and y's in it. Okay? So just, that's what we're trying to get to. Please shut that off. And I noticed that I got rid of the cosine thing, but I still have r's in here. They're not allowed. So, let's get rid of the r's. First of all, I'm going to multiply both sides by r. Multiply the right side by r, multiply the left side by r. Why? Because now I have 4x equals r squared. Back from our very first slide, remember that triangle XYR? If I use the Pythagorean theorem from that slide, you might recall that the hypotenuse squared equals the leg squared plus the other leg squared, the Pythagorean theorem. So really what I could do is I could write this equation as x squared plus y squared equals 4x. I now do have an equation that only has x's and y's in it. There's nothing else in there. So this completely is okay. However, I do want to point out that it probably would be to your advantage to do the following. Starting to look familiar? This is a circle with a radius of 2, with its center at 2, 0. Completing the square. This was in chapter P. We learned a long time ago. And that's the same as 4 cosine of theta. And in our next lesson, after the break, we're going to learn about these things. Circles, limicons, and roses. But this is just kind of one of the things that you can do going back and forth from polar to rectangular. So you have to get to the point where there are no r's, there are no cosines, no sines, only x's and y's. Questions? Okay, letter D is kind of a